Cool. Hey, everybody, and welcome to the Kubernetes Working Group for Multi-tenancy. This is our regularly scheduled Tuesday, December 1st, 2020 meeting. In our agenda today, Chris is going to go over the new provider repo, and then Adrian is going to lead a conversation about Kiosk, Loft, and some of the multi-tenancy working group projects, just to understand how we may or may not align there. And then Daniel was going to chat about operator multi-tenancy update. Cool. So I'll hand it over to Chris. And Chris, I will make you a presenter.
Cool. You'll just get to look at myself. I don't actually have anything to share other than you can click on that link in the Google Doc. Faye and I have started to kind of like pivot a little bit of the work that we're doing. We're still going back and forth between this repo with the incubator VirtualCluster project. But long term, the goals are to move most of that code base or a lot of that code base out of the multi-tenancy repo, and we're replatforming the actual API. I talked about this a little bit ago, at least a couple months ago, that we were looking into doing this. But the idea now is that we have a cluster API provider nested repo, and we're rebuilding the base API layer to do provisioning of control planes that are nested within clusters. The end goal being what we get out of VirtualCluster with syncing resources between, in CAPI terms at least, a management cluster and the actual tenant control planes. And yeah, if you're interested in getting involved or you've been working on or are interested in learning more about that, click on that repo. We have a call on Tuesdays right before this on every Tuesday at 10 a.m. PST, and the meeting notes are in the README. We'd love you all to be involved.
What kind of, so it's going to be sig-multitenancy that's the long-term owner of this now, is that correct?
Cluster lifecycle.
Cluster lifecycle, sorry. And did they do like a code review or something, like what, or a security review before it started?
Yeah, so where CAPI is right now, it hasn't gone through all of those. Every CAPI provider right now is under a V1 Alpha 1 through 4 API. We're in the process of redefining or defining what Alpha 4 is right now. Long-term plans are for API reviews and security reviews. We're going to be doing that on the way to beta, which will go across all the providers at that point. So for right now, we are there hasn't been one of those. We have a new design doc that we're getting the folks from CAPI involved in reviewing, which brings up a new way of deploying these. If you're familiar with what VirtualCluster was doing around the cluster version, the idea now is that each individual component has its own CR and can individually be mutated. So from etcd controller manager and the Kube API server, they're individual CRs, and then you have an orchestration CR that goes and deploys all of those resources, similar to how the ownership between, or the model between VirtualCluster and cluster version works today. So
cool. And is this going to cause a lot of disruption for like your customers, like your users already? I remember that you got called out by Apple during their KubeCon keynote. They're using virtual clusters, right?
I might work there.
Oh, that's me. Okay, right. I forgot you were there. Cool. Okay, yeah. We don't have to worry about that. Awesome.
Yeah, we did get a call out. Yeah, we didn't get to change that to say to be CapN before the actual presentation was recorded and all that. But yeah, in essence, the idea is we're currently working on VirtualCluster internally, and we're going to be moving over and pivoting to using all of the new CapN stuff as we kind of move forward, because it's being an alpha API, we kind of expected that there was going to be quite a lot of changes over time. Right. So yeah.
And so you have a bunch of non-Apple users too?
We do. There's more people getting involved, and this is exactly that. Another call out of, hey, if you're interested and if you want to help push this forward in new and exciting ways, please get involved. We have a couple of folks that have been talking to us from IBM, a couple folks from Red Hat as well, that have reached out about a couple questions. So yeah.
Sounds good. Thanks.
Thank you.
Anyone who's not me have any questions?
If no one has any other questions, check out the repo. There's a link in our meeting agenda to it. And then Adrian, we can hand it over to you to talk about Loft and Kiosk.
Yeah, so I've invited, is it Lucas or Lukash? How do I pronounce your name?
It's Lucas, hey.
Lucas. Hey, Lucas, and I see that Fabian's here as well. So yes, thank you to both of you for joining us. Sorry, my video is not working. I don't know if you missed that little part at the beginning. Yeah, so I was looking, I've been asked a couple of times about what's the difference between hierarchy controller and virtual clusters and Loft. And so I thought I would, and I couldn't answer that question, although I had a couple of ideas. So I thought I'd invite you folks on to talk about what you are up to at Loft with Kiosk and how that relates to, I think, all of the projects like DevSpace. I don't fully understand how all of your projects fit together. Can have a chat about what you're doing and then talk about whether it makes sense for us to join forces in some way, either share lessons or even just start sharing some infrastructure, because as you heard, the working group version of multi-cluster of virtual clusters is now going into the cluster lifecycle sig. So that might be something you could take advantage of if you wanted to. So yeah, do you have a presentation or something that you want to offer, or do you want to just start chatting about it?
Also, just as a quick note, since this has come up on a previous call, please do note that this is an open source meeting. This meeting's being recorded. We do post the recording to YouTube, so please don't deliver any state secrets during this call with regard to product roadmap.
Makes sense. Yeah, I put together a couple of slides. Let me share my screen.
Thank you. Yeah, that would be great.
All right, perfect. First of all, thank you so much for reaching out, Adrian, and for inviting Fabian and me to the call. Happy to talk a little bit about what we're doing at Loft and try to find out what the differences might be to what the virtual clusters and the multi-tenancy group in general is working on. In general, with Loft being a commercial product, what we're essentially trying to do is offering kind of like a basic building block for companies to build their internal Kubernetes platform on, rather than having to build everything from scratch. So we're trying to be a solution that you can adopt in days rather than months or years. That is extendable, but not doesn't require everybody to write like 50 operators before they can even give developers any access to Kubernetes. This is kind of a high-level architecture of where Loft sits. So essentially, Loft is an API gateway that essentially connects to external authentication providers for authentication. That can be GitLab or GitHub. It can also be LDAP or any kind of other enterprise authentication system. We're essentially just integrating with DEX here, to make authentication possible. And then users that are authenticated with Loft get access to connected clusters. And these connected clusters, users have accounts in these clusters, which essentially defines, their permissions, what they can do in the clusters, because Loft should be, like a self-service systems for users to create namespaces. And I think that's kind of a touch point with the hierarchical namespace controller. And then also to spin up virtual clusters in case they need, more power than a pure, basic namespace in Kubernetes. If they want to, work with their own CRDs and things like that, which might not be possible, in a single namespace. And in that case, you can spin up a virtual cluster. We do provide a UI and a CLI, but they're essentially just wrappers for kubectl. So everything basically goes to that API server gateway.
So in this diagram, sorry if you just go back one, when you say connected cluster A and B, are those real clusters, virtual clusters, or either?
Either, actually. So
okay.
Typically those are real clusters, but you can also connect virtual clusters technically. You can also create virtual clusters in virtual clusters and those kind of things. You can get as crazy as you want to, but I mean, typically a connected cluster is like a GKE cluster or EKS cluster or something like that.
And when you create a virtual cluster, is there any way to use it other than connecting it through your gateway? Or I guess I suppose you could just contact it directly via kubectl, right?
Right. I mean, generally when you with the CLI, when you're running, Loft create virtual cluster command, it spins up that virtual cluster and defines a kube context on your local machine for that particular virtual cluster. We do have a GitHub repository with instructions on how to deploy a virtual cluster, outside of Loft and set up the kube context manually. So that would also be possible.
Okay, cool. And so the Loft management cluster, I take it that is actually Kubernetes cluster, and you've basically just got like a proxy running on it. Is that roughly correct?
Right. So I mean, so the very the easiest setup. So if you're like a 10-person startup just starting out, not like a large organization, the easiest setup is you install Loft to a single cluster, and then you connect the same cluster that Loft runs inside, right? But that's optional. You can also have a separate cluster for Loft, and then you connect 5 other clusters to it.
Cool. Okay, thanks.
And Lucas, just to clarify, the virtual cluster you're mentioning here is not the same virtual cluster that Chris and Faye were just discussing earlier, right? Or is it?
Right, exactly. So we have our own proprietary implementation for virtual clusters. I think it is, I would say, closer to what Darren Shepard did about like 1.5 years ago with his like suggestion of K3S based virtual clusters. So it's a bit closer to that in terms of the implementation, but the goal is essentially the same, to spin up virtual clusters that run inside of essentially the namespaces of a host cluster.
All right.
Does it use the same mechanisms there in terms of like what the K3V project was doing, where it's in a single, where all resources end up in a single namespace?
Exactly. I think that's the biggest.
Cool.
I think that is the biggest architectural difference between what the multi-tenancy SIG currently has in the repo and what we do internally. So that was just a decision for us because of the way we built Loft. So essentially, Loft in the beginning, our first private beta product was essentially just provisioning namespaces. And then, the requests came up, how can we, provide users with the capabilities to, work on controllers, install CRDs, install something from, now Artifact Hub, previously Helm Hub, right? That ships CRDs, right? You want to have these capabilities and you want to give them to your users. But we had a self-service namespace provisioning system, right? And then the idea was, how can we extend that in a way that is very lightweight and allows users to deploy those virtual clusters themselves within those namespaces. So it was important to kind of give users that power to spin up a virtual cluster rather than having to make changes to the underlying cluster. That's essentially why we, started working on our own implementation.
And so that means like you'll have your own API, like a new copy of the API server, a little etcd cluster. Is that all correct?
Yes, exactly.
Yeah, okay.
All right. And if we go one level deeper in this diagram, so essentially, if you have a connected cluster, so let's start on the very right-hand side. In that connected cluster, and that's how kind of the open source projects that we work on fit together. So the first thing that Loft does is when you connect the cluster, it installs Kiosk to that cluster. And then Kiosk ships with a couple of basic resources. I think that is closest to the tenant controller, if I'm not mistaken, in the multi-tenancy repository. Where we essentially, add CRDs. We call them a little bit differently. So we don't call the tenant, for example, we call it account, an account quota and those kind of things. But essentially that's what Kiosk extends that connected cluster with, so that we have like the basics for multi-tenancy in that particular connected cluster. And then the Loft API server, as well, so the Loft instance in the management cluster, which may be connected as well, right? has CRDs on its own, right? For example, connected cluster is one of these resources, right? So each connected cluster is a CRD itself, and that lives in the management cluster. And then, there's user and team, for example. Those are all Loft CRDs that live in this management cluster. And then, we have an extension API server for certain things, that, kind of helps you with a list problem, because obviously you want users to be able to, list their namespaces, right? But it is hard to kind of reflect an RBAC. So we essentially have a resource called space, which a little bit abstracts from namespaces. But Fabian can go a little bit, or can talk about that in just a couple of seconds. As I said, we do provide.
That's similar to what OpenShift does, right? Basically, you have to maintain the reverse mapping.
Fabian, maybe you can jump in here.
Yeah,
exactly. OpenShift better than
so
me.
The same idea as like OpenShift has projects. So space is very comparable to like a project in OpenShift.
Right. Okay, thanks.
All right, and because everything is essentially a CRD, it's pretty easy to do GitOps with this as well. We do provide a CLI just for convenience reasons. If you don't want to build your own CLI, if you're a smaller team, or you want to integrate our CLI into whatever CLI you're working on, it should be pretty straightforward if you're doing that in Golang. We do provide a UI as well, which is basically just an abstraction for kubectl commands. So when you list clusters, it runs kubectl get clusters essentially, and clusters being a CRD of Loft. And as you can see here in the screenshot, if we dive into one of these clusters, you can also see Helm releases installed, like Nginx here or Cert Manager or whatever is installed in your cluster. And then Kiosk being one of these Helm charts that by default are installed into each connected cluster is obviously also visible for each cluster. And I think Fabian is going to talk a little bit more in detail about what Kiosk is, because as you mentioned before, and this is an open source working group, and Kiosk is really entirely open source and usable aside from Loft. So you can just install it to any cluster with Helm and get those multi-tenancy basic resources without even using our commercial product.
Yeah, so I mean, Lucas already mentioned it. Kiosk is basically some sort of like extension for Kubernetes in terms of multi-tenancy. So when we initially built Kiosk, we already knew like that Loft would be a product on top of it, but we wanted to have like the basic core open source. And we looked at like what you and the multi-tenancy group are doing. And we really liked the ideas. And we needed something like the tenant controller. But we had like certain requirements which we felt were not so easily doable with the tenant controller, which we ultimately decided to like build our own open source project where we can then build Loft upon. And basically Kiosk has like this basic idea of an account, similar to what the tenant controller has a tenant, as Lucas already mentioned. And in Kiosk, there are basically three big, or like two big components which Kiosk ultimately is implemented on. And the first thing is that Kiosk starts its own Kubernetes API server for certain resources, which are all virtual. In this case, you can see them in the top. That's the tenancy kiosk .sh API group, which mostly are just like basically views that reflect other resources, but circumvent the list problem, kind of like the project in OpenShift. And these are completely optional. You don't have to use them, but it just makes it easier for users like to query certain resources they have access to. And then we have space, which is like one of the basic building blocks, I would say, Kiosk builds upon, because space is like a very central resource, which is basically a one-to-one relation to a namespace, but the actual API server does a little bit more in the background when you create a space, for example. Because when you create a space through the API server of Kiosk, it also creates, based on your account definition that you have, certain resources in that space as well. For example, role binding or certain pods or network policies and so on. These resources are basically defined in so-called templates. So this is a little bit similar. It's like the underlying idea is a little bit similar to like what hierarchical namespaces are doing, but it's a different approach ultimately. So we want to try to accomplish the same goal, but we do it a little bit in a different way there, where you can define in the template basically resources, and then you have a template instance which instantiates these resources. A little bit like a Helm chart and like a Helm release. In this case, you even could define like a Helm chart in the template, and a template instance would deploy that Helm chart into a namespace upon like a space creation. And then you define an account. An account is basically bound to a user or a group in Kubernetes. And within the account, you define like limits for this account as well. So for example, you say the user can only create 10 spaces. And then the API server makes sure that the user does not exceed these spaces when it is contacted through the Kiosk API server. And it also creates templates that are specified in the account automatically upon space creation, and makes sure the user only gets access to the namespace after all these templates are deployed into the namespace itself. Another thing we needed for Loft was count quotas. So that's very comparable to what OpenShift has, which is called, I think, cluster resource quota. So here you basically say that a certain account can use a certain amount of resources, like pods, for example, in all of its namespaces together. So let's say a user or an account has 3 namespaces in which each 2 pods are running. You could define an account quota which limits this user to 6 pods. And when you would try to create a new pod in any of these namespaces, the request would get rejected because it would exceed the quota limit. So that's basically the idea in account quota. There's also account quota set, which is not implemented yet, but there was the idea that we could automatically deploy account quotas for accounts with a certain label selector. Lucas, could you switch the slides? Perfect, thanks. So here you see the relationship a little bit more in detail between those resources. And basically all these resources are just building blocks you can build upon, but you don't have to use. They're kind of like non-invasive, and Kiosk integrates with already existing namespaces and already existing resource quotas and namespaces and so on. It's just optional things that we thought are very handy when it comes to implementing multi-tenancy within a Kubernetes cluster. Yeah.
One quick sentence regarding this diagram. So essentially, we're looking at 2 different roles, and that's what I tried to outline with this diagram. So typically, you have the cluster admin, and then you have an account user. The cluster admin is the person that essentially has admin permission to the connected clusters. So that's the person that configures the accounts, sets the account quotas. In the future, we'll also manage account quota sets, but as Fabian mentioned, that is not implemented yet. And also defines the templates. And you can also define certain, so let's say you have a template for a network policy, or for certain resource quotas or things like that, right? you can also enforce these templates inside the account, right? So inside the account, you can essentially list which templates should be automatically instantiated in each space that a user creates. And then you have the user role, which is essentially the a user or a Kubernetes group or a service account, which is now using this account to authenticate with the cluster and gets the permission to list, create, delete spaces, which is essentially just a representation, an abstraction of a namespace, which they then work on with regular pods, deployments, etc. So it's really just about creating, managing namespaces and creating that abstraction for users to create a self-service system for them. All right, if there are no questions regarding Kiosk, I have a couple more slides regarding VirtualCluster and DevSpace, just to outline, what the differences are and how that all fits together.
I've got a question or two on this before we go back to VirtualCluster. So thanks so much. This is super useful. Can an account user, like a user group or service account, be a member of multiple Kiosk accounts at the same time, or is it one-to-many basically?
No, it's possible to have many accounts as a single user. So you could have like an account for, I don't know, development things, or then an account for production namespaces, which could have different configuration and use different templates based on basically what you want to do with this account. And you can choose.
Sorry, go ahead.
Sorry, and you can use which account to use basically when you create a space, which has just a field account where you can specify the account that you want to use.
Oh, where does that field go? Like in the namespace as an annotation?
Yeah, it's a label actually. Yeah.
A label, okay. And I think the only other question I had then was a template. So what does a template look like? I take it it's a Kubernetes object that basically just has free-form YAML inside it. Is that roughly correct? Yeah,
exactly. So we have basically in the template, you have two options. You could either define like a Helm chart, which has specific Helm-related options such as chart name, chart repository, and so on. And then you have this kind of free text YAML part where you can define like an array of YAMLs, which defines other Kubernetes resources that should be deployed inside this namespace.
And you've got to take it some fields that can be modified. Is that correct?
Yes.
Okay. So this is all open source, so I can just go look at this.
Yeah, sure. Yeah, this is completely, Kiosk is completely open source. All of the things I just said, you can just look up.
Hi, this is Fei. Thanks for sharing this. I have a kind of dumb question. So is space and the namespace, are they one-to-one mapping?
Yes, exactly. So it's basically just, a space is just a virtual resource that is returned by our API extension server. But internally, it's just like converted. So you can just convert any namespace to a space, and you can also convert any space back to a namespace. So it's not stored anywhere in the etcd. It's just virtual resource present in the extension API server.
Oh, okay. So I think in this figure you say users can operate inside namespace. So does user actually can access namespace, or they don't even allow to access namespace?
Yeah, they can actually also access the underlying namespace then. But so the main difference between like why users do not directly access they directly access namespaces, but they do not directly create namespaces. So they create spaces because during a space creation, we have the possibility to do extra things while we cannot like intercept a namespace creation, the user does. And that's basically the reasoning behind this, because then we can deploy templates, make sure the user can only access the namespace after all the templates were deployed into the namespace and everything is set up correctly, and then give rights to the user to actually access this namespace.
Oh, I see. So people still can access the namespace through the API, but
Exactly.
but they cannot list the namespace. List operation is forbidden, right? So they
no, the list of operation is allowed as well, but the list operation is filtered. So when you do like a kubectl get spaces, the API extension server will basically check, like through airbag, which namespaces you are allowed to view, to get, and then just return these instead of like the usual Kubernetes way. It's saying, am I allowed to list all namespaces or none? So we kind of circumvent this problem by implementing our own list operation for spaces.
So how about what if the user just type kubectl get namespace? So can they do that? Or?
No, that is forbidden.
Okay, yeah, okay, I understand.
Just to add another example regarding this, because I think that's probably the most complicated part regarding Kiosk, with the question that Adrian said regarding how does this fit together with the accounts. So essentially, when it works like this, if the user already owns an account, so is already connected to an account, so the account essentially has a just like an RBAC, like a subjects list. So if my authenticated user, whoever I might be, I'm authenticated with a token towards the API server as a service account or a user, right? And I access the Kubernetes API server and I'm listed in this account, I'm part of this account, right? And if I want to now create a namespace and, afterwards deploy something to that namespace or do whatever I want within that namespace, I would actually create the space resource. So I would not run kubectl create namespace, I would run kubectl create space. Or kubectl apply to be more accurate. And then this space resource has then a field account, which references which account I want to be using. And then we can essentially check, is the user that runs this HTTP request, right, this API server request, part of this account, and do we allow this space to be created? The space itself is not persistent. It's a completely virtual object, right? What we essentially do is we then create this namespace, we enforce the template instances, right, which are defined for this account, right, to limit this account. So for example, the network policy that has been defined in the template and referenced in this account to be, a mandatory template to be instantiated, that would be instantiated first inside this namespace. And then we would, also add RBAC to that namespace, etc., to essentially give this user or the subject or all the subjects that are part of this account access to this namespace to now, create deployments, services, whatever the admin has configured. And then we, that's what Fabian mentioned earlier, since you defined the account in this virtual resource, we also add this account as a label to the namespace so that you can now run kubectl list spaces, and we just check which accounts do you own, and then we essentially iterate over the namespaces and can kind of select by label and only show you those namespaces that you have access to, right?
Just one small correction. To find out which account can access which namespace is completely done through airbag. So we basically check, since we have like all the roles and role bindings, and cluster roles and cluster role bindings in the cache anyway, we basically just do the Kubernetes check if I can like get the namespace directly. So usually, for example, when you have like a role binding or like a role and a role binding in the namespace that allows you the right to get namespaces, you essentially get the right to get this specific namespace. And that's what we are checking there. If you are allowed to directly get the namespace, regardless of the label. So the label doesn't really matter for that. It's just pure role-based access control.
So I have a question about the account quota, because it seems like one account can have multiple space, right? Basically one, right? So I think the account quota should be accounting for the sum of the resource for all namespaces. Am I correct?
Yes, exactly. The account quota selects the namespaces by the label here.
Oh, okay. So, but there's no actually diving the quota across multiple namespace, or did you have that functionality, or you just every time you just check the sum of the resource of all the namespace cannot be over the count quota, but there is no detailed divvying of the quota to multiple namespaces. Am I correct?
Sorry, I'm not sure.
Oh yeah. So what I'm saying that because account quota is a quota for all namespaces, right? So,
Yeah.
but yeah, if you have two namespaces, how do you divide the quota into two namespaces? Or do you do that, or you don't do that? You just let people.
No, the account quota. So if you want to have different quotas in each namespace, you create a resource quota in that namespace. The account quota is for the use case that you want to like limit resources as a sum over all namespaces the account owns. So it's basically kind of like the cluster resource quota OpenShift has with the namespace selector of the namespaces that belong to a certain account.
Okay, I see what you're saying. So basically, account quota seems to check the aggregated resource quota of all the managed namespaces.
Kind of, yeah, but you don't need a resource quota, and it will not be created a resource. You can use that without a resource quota. That is like something.
I see.
So the account quota in the background does not create resource quotas or anything.
But
like,
I see.
So, but it's basically the same idea, yeah.
Okay, so there is no divide kind of thing, but you just check the sum, kind of.
Exactly. Yeah, you check the sum of resources across the namespaces that belong to an account. Yes.
I see.
All right. Are there any more questions regarding this diagram or Kiosk in general? All right, then I'll proceed with VirtualCluster real quick. So essentially, this is what we're trying to do, and this is an actual hotel in Amsterdam, by the way, which consists of 70 stacked houses. It's pretty crazy, but I guess you're already familiar with VirtualCluster, so we're all trying to work on this crazy mission here. So it's essentially about creating the single tenant experience, but inside or on top of a multi-tenant Kubernetes cluster, right? That's essentially what we're trying to do. Give everybody their own little house where they can do whatever they want, but then essentially having that in one combined multi-tenant, architecture. And for Loft, that essentially works like this. And I think, as I said, that is probably the biggest difference here. We'll take a Kubernetes cluster, have a controller running inside that Kubernetes cluster that now knows what a virtual cluster CRD is. And then as a user, I can now essentially create that CRD in my namespace, right? So I allow users to do that on their own rather than having to do that on the cluster level. And then users create their virtual clusters inside the namespaces. The in-cluster controller instantiates them, right? So spins up the API server, etc. And since that is, we're actually using the K3s API server here. It's a, as you know, certified Kubernetes distribution, etc. So it behaves like any other Kubernetes cluster as well. So I can now use this API server with, directly as an engineer or with scripts via any kind of UI or CLI or kubectl or Helm or whatever you want. And everything by default goes through our API gateway in Loft. But as I said before, you can also set it up differently. Essentially just deploy the virtual cluster, not having to go through the API server, but that is more manual work to do. And then, again, the API gateway is, capable of doing this for multiple underlying clusters. So as a user, I get a kube context actually for each namespace and for each virtual cluster that I create. So it doesn't really matter to me how the underlying cluster infrastructure is. I just work with my namespaces and with my virtual cluster, and I switch my context and then get a new virtual cluster or a new namespace access depending on default namespace configured in this kube context. And then the API gateway essentially routes requests to the connected clusters and Loft. And then last but not least, since you also asked about DevSpace, Adrian, just put another slide in here regarding DevSpace. So DevSpace was essentially the tool that we started out with in 2018. So I think it was like developer tool number 3 or so that was created for Kubernetes. I think by now we're probably at like 50 or something like that open source tools out there that you can use for Kubernetes-based development. The idea was essentially to replace Docker Compose and make that switch from Docker-based development towards more Kubernetes-based development. In that regard, it is similar to the 2 projects that were already in the market when we got started. So when we started in 2018, there were 2 projects out there already. That was Draft, which I think spun out of the Azure team or at Microsoft somehow, and then Scaffold, which is I think connected with Google. And both tools had essentially a similar idea that we're following as well, that the developer is assumed to have access to Kubernetes cluster, whether that be Minikube or a GKE cluster or whatever, and then essentially can use a CLI only tool, so no server-side component required, to kick off something like a CI/CD pipeline, which deploys an application to a namespace in Kubernetes, and then start port forwarding and log streaming to essentially get a hold of that application while it runs in Kubernetes. So that was essentially the state of the art when we got started with DevSpace. The thing that bothered us when we saw that was essentially that the idea, at least in 2018, was whenever there's a file change or where you want to reiterate over this, change your application, then you had to rerun this local pipeline. So I think we were the first tool that shipped this bottom part here, which was essentially an idea of how to solve this kind of hot reloading experience, because on your local in your local development environment, on your local laptop, you're just used to rerunning your applications without having to rebuild images, tag them, push them to registry, etc. Right? That's a lot of steps involved to instantiate something in Kubernetes. So we wanted to have it closer to the local experience, where you just change a file and you run your go run command again, or where you change your file and you have something like a hot reloader, like nodemon for Node.js, or I think Spring Boot and others in Java have hot reloaders as well. So we thought, how can we achieve this? And the way we did that with DevSpace is essentially in this pipeline, in your configuration file in DevSpace, you can make certain overrides. For example, to the Docker file, you can say, please append those 5 instructions to the Docker file. Please only build to the build stage rather than to my production stage, which is only a binary in a distroless image, right? What am I supposed to do there as a developer? So those kind of things you can configure in DevSpace so that it only builds to your build stage, and then installs a hot reloader, installs a remote debugger, and those kind of things. And now you have an application running inside a namespace with a container that is more powerful than maybe your production image, which is very stripped down to the essential application. And then we establish a file synchronization between the local file system and the container file system. We essentially do that by injecting a little binary inside the container. And that binary, we establish a connection between the local file system and the remote file system. So we're watching both file systems essentially with file watchers. We also run over, the tree of files for the particular folders that you configure. And whenever we see a file change, depending on your configuration, we sync the file changes from your local file system up to the container file system, and vice versa if you like to configure this. And because we do that directly inside the container with this binary that we're injecting, it doesn't really matter to us if your underlying folder that you're synchronizing to is ephemeral storage, or if you're using a persistent volume that you mounted inside the container. It doesn't really matter to DevSpace, as long as we can inject that binary. So we're essentially having read-write permissions on the file system, which you can pretty easily change by changing the pipeline, adding things to your Docker file, so that everything that typically security people would not want you to do in production, like running your containers as root and things like that, right? Makes it easier for developers, but it's something you probably don't want in production. But with that way, you can have a hot reloader inside your container running that essentially restarts your application. And then you really get this great experience where you change line of code in your local IDE. You have dev space running in the terminal of your IDE, right? And then you see the container restarting, you see the log output, and you refresh your browser or whatever you're doing, and you essentially, get a really great experience of how to work inside a Kubernetes cluster with the capability to connect to services that may run in other namespaces, like a shared, Kafka message queue or things like that, or a shared large database, or anything that you can have in GKE or AWS, which may be connected to your Kubernetes cluster. And then Loft essentially connects to dev space in a way that Loft may be the provider for you to spin up your namespace, spin up your virtual clusters that you then use to do your development work with dev space with. So that's essentially how it fits together. As I said earlier, we started originally with dev space and then released Kiosk, and then now got started with Loft. That was essentially the journey.
Thanks for that overview. That was really helpful. Is this the last slide, by the way?
Yes, that is the last slide.
I know that we got one more thing on the agenda. I have more questions to ask. I'd love to go on and talk a little bit more about like how we could collaborate in the future, but we might be out of time for that. Daniel, how much time do you need for the for your item?
Yeah, I just need a minute or two. You can definitely just go ahead with additional questions.
Okay, sure. Okay, so I'll cut it off in 8 minutes so that you can have the last word. So yeah, I think that my question would be like, it seems, so Faye and I were actually just talking about the tenant CRD, which as you said is kind of the most direct analog for Kiosk. And so, yeah, I agree. Those are kind of two alternatives, and I can see the differences between them. HNC is at a lower level, and I think I can see, I don't know, I feel like there could be, in some ways, it could operate at a lower level than Kiosk, and I could imagine Kiosk being rebased on top of hierarchical namespaces. In another way, it has a fairly separate model, like this whole like system of accounts that is separate from namespaces. I have considered actually adding, very similar to what you call templates, I have considered adding those to HNC. I even wrote a very quick design doc on it once upon a time. But at the moment we don't have anybody who really wanted to go implement that, and we weren't rushing to do it ourselves. I think that would be the main thing, is that if you were to rebase this on top of hierarchical namespaces, there would be a bunch of changes to how your customers used it, and that might not be worth the change them right at this point. Is that how you're thinking as well, or have you thought about that?
Yeah, we've just briefly talked about that last week after you reached out. And so I think, as you said correctly, I think the hierarchical namespaces is closest to what we have in terms of templates and template instance. Because it essentially allows you, to have like a parent namespace with certain, network policies and, restrictions that you want to apply to the child namespaces. So what we are thinking about is essentially we could extend Kiosk in a way that the account gives you the option to either specify a template or specify a parent namespace, essentially, for all spaces that this account creates. So that would not be like a breaking change for us in Kiosk, but it would allow us to extend it to essentially incorporate hierarchical namespaces as well.
And that also gives you a nice place to put that account quota, which right now is cluster level, and so therefore quite difficult to control access to via RBAC. If you can put that account quota into a namespace itself, then it becomes much more feasible to limit access to it.
Yeah, because that's something we haven't discussed yet, but that sounds definitely interesting. That might also, solve the issue, because as I said earlier, account quota set is something we've been thinking about. So essentially how to create account quotas automatically once you're creating an account. That is something we've been, we thought about this implementation for account quota set, similar to essentially like a replica set, essentially. That was the analogy, right? But we're not fully happy with it yet. So that might be something to explore with hierarchical namespaces as well. That definitely is very interesting to look at, yeah.
Yeah, I think I'd love to continue this conversation afterwards. And as for VCs, I'm not too involved in those, but maybe Chris and Faye, anything that you, I don't know, how are you guys feeling? And Chris and Faye are the leads, or Faye's always the person that has been my go-to for this. But I think Chris is pretty involved now as well. Any thoughts about whether it makes sense to have any kind of collaboration? Or I mean, maybe another way to put it is, for the Loft folks, like, why was the working group multi-tenants, was the working group VC concept not ready when you started to, when you needed one? Is that why you didn't use that one?
Yeah, I think that is, I mean, it's pretty similar to hierarchical namespace as well. So when we started building Loft, that was essentially December last year. So that's like over a year ago. And I think, both projects have probably gained a lot of maturity compared to when we first looked at it. So, and since we didn't know, how much, so, I mean, we're a small startup, right? So we need a lot of flexibility. A customer complains, hey, this is not working, so we need to make a change right now. And that was essentially for us, the thing where we said, okay, let's take a look at, the option to create those projects ourselves, where we can essentially make changes very, very quickly. And then later on, see if we can somehow merge that back, especially since Kiosk is fully open source, and it was always clear that it will be open source. I mean, we even said that at some point, if people like it and want us to put it in CNCF or something like that, we'd love to do that as well. So we're really open to all of these things, but that was mainly the decision. Both projects were very early when we looked at them. Actually, all three projects, the same accounts for the tenant controller, right? So that was the main decision for us. But I think going back now and taking a closer look at all projects again and see where we can, join forces on certain things, that is definitely something we would love to do.
Yeah, I personally, my current thought is, I think Kiosk is many component concepts very similar about our current tenant controller design. Like, account similar to tenant CRD, and the space is very close to the tenant namespace CRD. In addition to that, they have account quota stuff, which is definitely a good supplemental to current tenant. So I feel Kiosk has done, I think, a better job than what current tenant operator has been doing. That's my feeling. In terms of the virtual cluster, I see the differences now, and sometimes because you use I fully understand your choice, and yes, indeed, the project doesn't come to motion until early this year. So for that, I feel there are some, maybe what Chris and I was trying to do may not be. It depends on you. Do you think if that fits your requirements? Because I think your tenant master, you use a case 3S. So you probably don't have this, tenant component management problem. And so in terms of thinking logic, I think it may depends on the use case whether people really use that or not. But our design was very we were trying to keep the Kubernetes API semantic as inaccurate as possible. So that's you guys probably will face some compatibility issues if you combine all resources in one namespace. That's my guess. But if you intend, if you have some thoughts about that, so we'd like to talk about it, or you think there is something that the virtual cluster, even upstream virtual cluster, can be enhanced to certain use case, that's certainly welcome.
Yeah, definitely. I think that discussion would probably require a couple more hours, but definitely looking forward to have a follow-up call on that.
Why don't we follow up on Slack, and then maybe we can schedule some one-off meetings if we want to keep talking live. I just want to make sure there's enough time for Daniel, but thanks so much, Fabian and Lucas. This has been very informative. So thanks for taking the time to come and present.
Sure, definitely. Thanks for the invitation.
Thanks.
Thanks. Daniel, you want to go ahead?
Yes, hi everyone. I just had a quick update. As you may recall, back in March, I gave a presentation to the multi-tenancy working group around some of the work that is going on around multi-tenant operators. I'm going to drop a link in the chat here to that presentation. We've been working a lot internally on how to grapple with some of the complexity around multi-tenant operators, and we've made some pretty big internal decisions around sort of the path forward. And I was thinking about maybe coming back to the group in light of some of these changes and doing a new presentation. I think, the reason that multi-tenant operators are relevant is sort of multi-tenancy is desired since it lets you run different workloads. And since operators are some of the most complex type of workloads, they're relevant. So yeah, I was just wondering if people are interested, and then I can put together some slides for a presentation outlining sort of the change in strategy.
I'd definitely be interested.
Great.
Well, I think that this is really relevant to some stuff we're all doing.
Yeah, I think it is, and it's interesting for us to gauge sort of, your guys' reactions based on sort of what we're doing, because I think actually it integrates. It may actually integrate better with some of the projects like the Loft project that was presented and the VirtualCluster stuff versus what we had before with sort of operator groups and looking at it from a single cluster perspective. But yeah, in that case, great. I will try to put together a presentation. I know Evan's on the call, so me and him will look at it and come back to you guys with something maybe in the next couple of meetings. Yeah.
Awesome. Sounds really good. Thanks.
Thanks.
Okay, thank you, everybody. This was a really great presentation. And if you have topics for next week, definitely, or for 2 weeks from now, definitely put them on the agenda. It feels like there might be more to talk about with Loft and everything. So I think we definitely appreciate, if people have questions and stuff, I think let's keep the conversation going. But cool, chat with y'all later.
Thanks, everyone. Bye.